Hi, this is Maggie. In this video we're going to talk about layering groups and changing the appearance of sprites. Sprite groups allow us to manage collections of sprites. Instead of keeping many references to individual sprites, we can keep one reference to the group, similar to a list. Sprite groups have a method that will clear the sprites from the screen, replacing them with a background image called clear, a method that will send an update message to each sprite in the group called update, and a method that will send a draw message to each sprite in the group called draw. Sprite groups also allow us to check for collisions between an individual sprite and the group, or between two groups. There is no guarantee that sprites in a group will remain in any particular order, and therefore no guarantee they will be sent the draw message in a specific order. You might add sprites to a group hoping that the last sprite in the group will draw last, but you cannot make that assumption about the group. Therefore, if you want to layer your drawing, you will need to place your sprites in more than one group. I saw a video of fireworks behind Big Ben in London, and I thought creating a similar scene would be a good example to illustrate this. Now here's what we're going to build, and it's really busy, but it illustrates both the layering of sprites and changing the appearance of a sprite. In this program, the fireworks are behind the Big Ben sprite, and the snowflakes are in front of it. Let's begin with a template that includes a generic sprite definition and a generic group definition that adds the sprite to the group with clear, update, and draw messages at the bottom. I recommend you make a template for yourself with generic code and lots of useful comments anytime you learn something new, as it will make developing with your new knowledge much easier. I'm going to rename the template snowyfireworks.py. So what I'm going to do to begin is just load in the Big Ben image and the snowflake images. This is the simpler idea, the layering of groups. And I'm going to make a sprite class for Big Ben, even though it's not going to do anything but sit there looking impressive. And I'm going to make a sprite class for a snowflake. A snowflake is going to fall down the screen, and when it disappears below the bottom, it's going to recycle itself up above the top of the screen with a new X location and a new speed. So I'm going to copy my generic sprite class twice. And name one architecture, which will be my general term for architectural elements that just sit there, and I'll name the other snowflake. And we'll have architecture take its image as a parameter to the initializer, of course, and also an X and Y coordinate. And we'll leave super init from our template, and the image assignment from our template, and the rect assignment from our template. And then we'll set the rect's top left coordinate to the XY coordinate passed in. I'm going to delete the update method because the architecture will not update. Down in the program, I'm going to annotate the Big Ben image and the sprite of type architecture, and I'll have a group called architecture group, which I'll annotate and instantiate. And then in the Assets section, I'll load in the Big Ben image. I'll instantiate an object of type architecture with that image, and I'll position that at the bottom of the screen and then a little off-center. I'll make its left side the center of the screen. I'll pause and do that. At the bottom, I'm going to change this generic code to refer to the architecture group. So clear, update, and draw. Nothing new here, but let's run it and make sure we haven't made any silly mistakes. That looks great. I've left the black background because this is a nighttime scene. On to the snowflakes. So for the snowflakes, I have 4 different snowflake images, which are basically white blobs I made in image editing software. I'll randomly select a snowflake image and use it to initialize a snowflake sprite, which means I'll have to import random at the top. Let's define the sprite. It's going to need a speed, which I'll annotate and call dy. In the init method, I'll leave the superclass init, the image, and the rect parts alone. I'll randomly generate left and top coordinates for the rectangle of the snowflake so that we start in the middle of a snowstorm. The snow will be all over the screen. I'm going to randomly generate those coordinates so that the images might be a little off the screen so the snow doesn't look oddly confined to the window. I'm going to randomly generate a dy value between 4 and 10 because I looked at snowfall videos online and that looked like a natural speed to me. Now in the update method, I'm going to add dy to the top of the rectangle, and then check if the top of the rectangle is at or past the bottom of the screen. If it is, I'll set the bottom of the rectangle to the top of the screen, so just about to fall into the window. And then I'll randomly generate an x coordinate and randomly generate a speed using the same parameters that I used before. Okay, now down in the main program, I'm going to annotate a list to hold the snowflake images, one snowflake sprite and a snowflake group. And I'll load in the images to my list. Now I'll, in a loop, initialize a snowflake sprite with a randomly selected image, and then add the sprite to the snowflake group. I don't need to keep a reference to any of these snowflakes. I thought 50 snowflakes looked pleasantly snowy and not like a blizzard. I'll add that code in and come back. Now down where we update and draw, we're going to clear, update, and draw back to front. So Big Ben is behind the snowflakes. So we'll do Big Ben, then the snowflakes, for each operation. Clear, update, and draw. Let's run that. And it's a charmingly snowy evening in front of Big Ben. Now I'm just going to change the order so you can see the effect of layering. I'll move the clear, update, and draw of the snowflake group to happen before the architecture group. And run that again. You see how odd that looks. The snow falls only behind the clock tower. Okay, and we'll put that back. Now on to the fireworks. The fireworks are an example of how you can change the appearance of a sprite with or without moving it. So you might want to animate a flag blowing in the wind, or a neon sign, or a digital countdown without moving the sprite that's animating. Or you might want to animate a moving sprite, like a person walking, or wheels on a car turning, or a squirrel jumping. Most things that move have moving parts that make them move. So let's look at the fireworks, each of which is a single sprite that is animating itself. I may have mentioned previously that I am no artist, but I did my best to create 6 images representing a firework exploding in the sky. As with the snowflakes, we'll load the firework images into a list. In fact, I did 2 sets of 6, a blue firework and a red firework. I'm going to pause the video and annotate those lists and load the images in. You can see that I named those fireworks images so they could be loaded in using a loop. Use the loop control variable where the integer is in the name to create the name red underscore firework 0.ping, red underscore firework 1.ping, etc. Okay, and I'm going to annotate a firework sprite. Even though I haven't defined the class yet. And I'm going to annotate and create a group for the firework sprites. And I'm going to loop and generate 3 blue fireworks and 3 red fireworks. And I'm going to give them random locations, again making sure they're not confined to within the window by generating locations a little to the left of the window up to the size of the window. I could randomly generate either red or blue or another color if I'd made images for them, but that involves putting the lists in a list, and I thought I'd make this a little simpler. It doesn't really matter because the fireworks are all at random locations on the screen. There. Now, I'm going to go down to the bottom and have the fireworks group clear, update, and draw. These will be behind Big Ben, so I will clear, update, and draw them before the calls to clear, update, and draw for the other groups. Now let's go make the fireworks sprite. So from my final generic sprite, I'm going to change the name to firework. And I will annotate 3 fields for this. The list of images that is going to cycle through to draw a firework. Counter that it will use to determine when to switch images, and an image index. Which will be the index of the current image being displayed. In the initializer, I will take the list of images and the X and Y coordinates of the firework, which were randomly generated. I'm going to randomly generate an image index between 0 and the size of the list of images minus 1, the last index in the list, so that the fireworks start off at different states of explosion. I'll set my images field to the parameter, and I'll set the image field by indexing into the images using the index I just generated. So there are 6 images, and maybe I generated index 2. So this index into the list of images pulls out the image at index 2 and sets that to the current image. Then I'll set the rect, and I'll locate the rect. And I'll set counter to 0. Now in update, we need to increment counter. Remember, this method will be called according to our clock 30 times a second. I thought that updating a firework over the course of a second looked good, so I'm going to count to 5. So if self.counter mod 5 is 0, then I'm going to increment the image's index. So remember from our example before, if image 2 was the current image, this will make image 3 the current image. However, there's the special case of when we're already on the last image. What do we do when we're on the last image? Well, that firework is done exploding. We'll recycle though, just as we did with the snowflakes. So we'll go back to the 0th image and we'll generate a new random X and Y location. And then, now that we've either incremented our image to the next one or recycled back to the beginning, we'll set the image to the image we've chosen by indexing into the list of images using the new index. Okay, let's run that. And it's crazy fireworks show in the snow again. So, to summarize, to layer the drawing of sprites, put the sprites in separate groups. To animate a sprite, either in place or as it's moving, you can give the sprite a list of images and an index into that list, and each time the sprite updates, increment the index and set the image to the image at that index, remembering to wrap around at the end of the list. If 30 times a second is too fast, keep a counter and decide when to increment the index using mod. I hope you enjoyed this tutorial. To practice, choose a scene to layer that has an animated element. Find some images to use and build the scene with Pygame using multiple groups. When you can layer sprites so that your scene looks the way you planned, and you can animate a sprite, you're ready to move on.